Okay, this is part 2 of our Solidworks endeavors of making an injection mold, my thought process behind when I make an injection mold and examples. So the first one was more of like an introductory course to SolidWorks if anyone's interested in kind of learning the basics. And this video is actually going to go through making an injection mold. It is kind of scripted now compared to the last one. I was kind of just freeballing it, but this one is actually kind of scripted because I want to make sure it's all the right dimensions and everything. So, so now we have Jarek. I don't know how to pronounce your last name, Jarek, but introduce yourself.
My name is Jarek Griskowitz. I'm a sophomore. I'm trying to learn from Alec here on how to do everything.
Yeah, so he'll be kind of taking this over, like injection molds when I'm gone, and then maybe teaching others about different designs and stuff. So here we are. Here's basically, this is going to be the end product. I'm going to start over, but this is basically what we're going to make. It looks like a little Lego, and we can basically see that it has our little 2mm diameter spiral on the inside, and so this is our injection mold. Then I'm not going to show the clamp, but let me, I'm not going to show it on SolidWorks, but here is a little 5-second video that I made on SolidWorks. So it's basically, there's the injection mold, and the clamp works in such a way that it just basically clamps down. Like I said, I'm not going to make a video on how to make that. There's a YouTube video that you can kind of model it after and then make it yourself. But
does the clamp fit into the little holes on top of that injection mold pretty perfectly then?
Exactly, yeah. So that's basically, let me show some more pictures. It's pretty cool. This is the very first clamp I ever printed, and it still is used since my end of my sophomore year, I think. So still works very well.
What material did you make it out of?
So this was a tough resin. This was on the Form 2 Formlab printer. And so this was before we got our Form 3. It was on the second version of their Formlabs printer, and it's a tough material. So it's very, very rigid, which is what we want. We don't want something flexible or anything. So I'm going to go more into that and like when I do preform and Formlab actual printing videos. So, but yeah, that's tough resin. Okay, so let's get a new part going. So file, remember how I did this yesterday, file, part, okay, don't worry about that one. Okay, cool. So if you watch the introductory video, if you already know what you're doing, Jarek said he's an intermediate SolidWorks level, and so he knows pretty much everything that I'm going to be doing, like these planes and moving around on planes. So we're going to start off on the front plane. I am going to do a sketch with a circle of 2mm, and I'm going to move this 2mm, double click, then smart dimensions into a 2mm circle. We are then going to use our, I think I mentioned it on the first video, but a spiral. Let's see. Yeah, okay. So then our pitch is going to be, okay, sometimes you're going to have to play around with this, but pitch is basically, we're going to have a 2mm diameter spiral. And if you think about it, let me just show you first, and then I'll explain what it is. And then the revolutions are 1.087. I'll tell you all why this makes sense in just a second. Clockwise, and spiral. There we go. So there is our spiral. Okay, so our pitch was 3. So if you think about it, there is 1mm of the half of spiral right here. There's another millimeter here. So there's 3mm in between this spiral, like from one edge to the other. That's what we want. We want a millimeter space in between each of these spirals. The revolutions kind of show how long the spiral is going to be, and this 2 mm diameter fits 60 microliters of hydrogel when we make this. I've made an Excel sheet of different IEQs, which are island equivalents of volumes for a certain amount of, islets per volume in a hydrogel. So that also just depends on what you're making. This was specifically 60 microliters for a 2 mm diameter spiral. Jarek will, again, he'll know all this down the line. He's going to know the Excel sheets. He's going to know everything that it needs to know about it. So here's our starting spiral. I'm going to show what the gel is going to look like. I'm not going to make the molds real quick. I'm actually just going to first make a sketch. So I need to make a new plane. And I'm going to do it right there. As you can see how it's kind of on that spot. I don't know why it's so big, but there's that. And then we're going to make a circle. There we go. On that plane, right on that dot. And it's not going to highlight. Don't know why. So I get as close as I possibly can. Right about there. And then kind of scroll out because it's going to then delete if it's too small. And a smart dimension. And like I told Jarek, I'm not any type of expert. You can probably somehow do this a lot quicker in any other way if you're an expert, but I'm not. And Jarek, do you have any tips? Do you think I'm doing this any weird way?
I mean, the fact that you made an extra plane a little bit confused me a little bit, but
okay.
Well, I did that for a specific reason. Because I don't know the correct word, but does that spiral that you made, is it like tilted at all, or is it basically, level going around?
Yeah, so it's in its 2D planar portion. Let me just make this first. Here we go. I just was gonna show it first, but so this is called a sweat boss base. I'm gonna answer your question. Just give me a second. So a sweat boss base is making an actual molds or 3D form. So it's following this, or it's making this circular 2 mm circle, and it's following this line, this spiral line. So that is what the gel is going to look like inside. Answering your question about making another plane, so this spiral is made on the front plane. The new plane that I made, it had to be in 3-dimensional to make this circle, to make this whole spiral 3-dimensional. So making that new plane on that dot will make sure that this circle is basically perpendicular with this plane right here to follow this line. Does that kind of make sense?
Yeah, it makes more sense. I thought that so you see how like the end of that one spiral, I thought it was like parallel to the first initial circle you created, but now that I see that it's at different directions, it makes complete sense.
Yeah, cool. So one thing that I want to iterate is when you're making an injection mold, or again, this is my thought process, you want to make the sketch first. And then you want to save that sketch so that you can do what I just did. So I'm going to save this sketch. My tutorial videos, practice 2, 2 mm diameter sketch. So you want to save that, and here's the reason why. Let me move over to this right here. I didn't mean to have this actually built right here, but this is the sketch for a blood vessel branch that I made. As you can see, there's a lot of planes to going out of this blood vessel to make this look like what it's supposed to do. And I don't know, Jarek, if you saw it, but this is what it turned out to be.
Cool.
So it helps to save those sketches so you can go back and change anything instead of having to remake it. Does that make sense? So I'm gonna exit out of that one now, so we don't need it. Okay, so let me sweat boss base again. Here's selecting this sketch profile that is on that other plane that we made, and then this this spiral to make This is what the hydrogel is going to look like when it comes out of the mold. So I like to save that because this is able to be translated into COMSOL, because when we have this COMSOL connection, do you know what COMSOL is, Jared?
I do not.
So it's basically it's a program that we use for measuring oxygen and nutrient transport through these hydrogel barriers to get into these islets and keep them alive and oxygenated and stuff. So having this on SolidWorks and having that connection to COMSOL is a good way to just kind of transfer it over instead of having to build it in COMSOL, which you could be end up in some different type of size. So that's just something for in the future. Yeah, that's it. Cool. So we got that. Any questions so far? There we go. So then file. So I'm going to reopen my sketch. So you can see right here how I still have it here. Now I'm going to be right here. So now I'm going to actually make the injection mold. So when you make the injection mold, you got to make a base that is big enough to kind of encapsulate this whole type of design, whatever you're doing, whatever design you end up doing. And so you want to sketch in our front plane again, that first one that we were at. And I'm going to do a square and smart dimensioning to 14. So these are already pre-planned numbers. Whatever design you want to make, you're going to have different numbers depending on the size, the shape of the material, and everything. You're just going to have to kind of find on your own. So, but this is kind of my process: is make a sketch, then you make the injection mold around it. So now we're going to go to our extrude boss base, which is this is a preview of what it looks like. So Jarek knows how to do this. This is easy money. That's the easiest thing you learn when you first learn SolidWorks is how do I extrude something?
Yeah.
Exactly how you do it. So 3 millimeters is typical, is what I use for a good sufficient type of kind of fit when it fits. You'll see.
Is there a reason why you chose that as opposed to something thicker, or does it really not matter?
So being the designer of this, a lot of it was kind of just, oh, this looks good.
Okay. That's fair enough. Yeah.
Yeah. So, because think about it, I mean, this spiral. Let me just cut this first. So now I can use this swept cut instead of a swept boss base. It's the same thing. Swept cut. You're going to select that profile. Right. That's right here, the circle, and then this curvature that we're going to follow. And now it's going to cut all the way in half through that right there. So that is what the spiral is going to look like. And the question that you were just asking was any type of reason. Not really, but having a 3 millimeter will give it enough kind of support through when you're compacting it together through the middle. I don't know if that makes any sense, but kind of got to trust me on that.
No, it does.
So cool. So now this is our sketch. Now I'm going to go back here. I need to make the kind of the lip portion of it, and that will happen doing, I need a sketch on this back part. Let me know if I'm going too fast, by the way. So I know Jarek has something to do. He's got a couple tests this week. I don't want to take up his time, but here we are. So 18 millimeters is a good distance away from this first kind of box to have a sufficient fit when it is printed out. Because you got to remember everything is going to be real here. Like you can, a lot of people use SolidWorks just to like kind of simulate things, but this is going to be like actually printed out. So you got to think like, can the printer actually have this size and or like print this size? Like air hole, when I show the air hole, it is barely going to be printed on a 3D printer because it's so small. So everything that you do, you got to realize in real kind of physical realm that is this going to work? So here we are, and I do 5 just because the clamp supports that are on is actually 4 millimeters, so it'll go through there. I'll show you a little bit. So now we have our bottom piece of our injection mold.
So that bottom piece is just for support of the mold piece that you made first, correct?
Yeah, so you don't even need this, to be honest.
Okay.
But I do it for having the clamp sufficiently like attaching to it and coming together so that we have perfect flow and perfect kind of pressure to make these injections happen. So yeah, so that's that first bottom part. But now we have to make an injection port. And so what I do is I build another plane, another reference plane right on this portion right here. And when you build a plane, I don't know if you, Jared, have you ever built a plane on top of other things?
I haven't done much of that, no.
So when you pick another plane, what you want to do is get like edges, because if I picked this face right here, for the reference plane, if I pick that, then it's going to go like way off the face, but you want it on it. So I like to use edges when I do that. I don't know why the face one, when you press it, it goes so far away, but that's just I don't know. And so yeah, so there's that. And then what I do here is I make it clear so that I can see where these points are, right at the end of the spiral. Then I make a sketch on that plane with a center line that goes from that end point to that end point. And then I do a center circle that will be 1 millimeter. And this is for the injection port. So this is where you stick the pipette tip in to get it to inject the hydrogel that we use. So now, as you can see, it's built on that plane, and I'm going to basically extrude cut all the way through to this end of the spiral. So I'm going to do an extrude cut.
Is there a reason you want that injection point in the middle of the mold? Like, would it matter if you made the injection point at the bottom or the top? Like, does that make a difference in how it ends up?
So so that was the first question. When I first got this project, I was like, can't you do it anywhere? Like, it would be much easier. And yeah, no, you would think so. But when you have eyelets and that are so sensitive and to like dying from like shear forces, you don't want it to kind of, if you're injecting from the top, think about it. When you're injecting from the top, these eyelets are making such a quick right turn or left turn that actually could kill them. Based off the shear forces. So when injecting just straight, that kind of gives them room to get through the spiral and then slow down when it gets to the end. So
okay.
Instead of hitting these walls, that'll kind of, what was that?
Basically, yes, it does matter.
Yeah, it does matter. And I just wanted to kind of, point that out because that is a great question. That was exactly my first thing that when I talked to Dr. Weaver about this, it was my first thing. I was like, can't you just do it anywhere? It would make it so much easier. So yeah.
And then you also said, so you inject from holding the pipette up and then the cells go down. So like do you inject it horizontally? Kind of what direction do you do the injection?
Yeah, no, it's horizontal. You don't want to do it going down. That's
so what stops the eyelet cells from exiting that same exact hole? What keeps them in that clearly defined space?
Yeah, so there's an air hole that I'm going to put at the very end. And technically, you know, it's not going to stop them. And you might lose some when it comes out the air hole. But whenever you have an injection, you have to, and you don't have an air hole, the liquid itself is not going to get in because the air is going to be trapped. So having that exit air hole is, you know, crucial to actually making an injection mold. But making it as small as you possibly can is even more crucial, because then you won't have just straight flow all the way through. And I'm going to show that in like a little bit. But no, that's a great question actually. So, so this is the top part is actually, or this bottom piece is almost done. I'm just going to go back here and make the points for the clamp. And I'm actually going to hide this and take that away. So, okay, so now it's the back part to fit the clamp. And I'm going to sketch on it this center line. I haven't even been looking at this to make sure. Yeah, no, that's all good. Okay. Actually, I'm going to make a circle right on that middle part right there. Smart to mention. And this is where tolerance comes. You know what tolerance is, Jared?
No, not exactly.
Okay, so tolerance is okay, when you have a box, two the same size boxes, right? You won't be able to put them inside of each other because they're the same size. So you got to make one bigger than the other to be able to put a box inside of a box. So basically what we're doing here is so this is 2.1, the clamp, the pinholes on the clamp, or the pins on the clamp, is 2 millimeters in diameter. I'm making this hole 2.1 millimeters in diameter, and that's because it won't fit if it's 2 and 2. So I like to use a point. Excuse me. I like to use a 0.1 millimeter tolerance when I'm using flexible resin, because you have a little bit of that flexibleness. But when you get into more like tough on tough materials, then you want to do like a 0.15 or a 0.2 millimeter tolerance. And SolidWorks has this toll analysis, which is a tolerance analysis. I've never used it. I don't know how to. I don't plan on trying. But if you want to and make it perfect, then that's on you. You can more than welcome to. But I don't do that. So, okay. Now I am making these diagonal lines right here. It'll make sense in a second. Just give me a second. Okay, now I'm going to delete these lines. I just wanted to make sure that they're spread apart evenly from each other. And now I do a smart dimension, which is, now this is what I have to look. I think it's 7.4. Yeah, 7.4. 7.4 millimeters away. So again, this depends on the type of clamp that you eventually may build. Who knows? Oh, I guess I did this one wrong. Who knows what eventually you're going to build for clamp wise. So you just got to make sure your piece fits on that clamp, and that's what I'm basically doing here. And now I'm going to make circles at the ends of these. They're all going to be 2.1. I just copy and paste it so I don't have to keep on typing because I'm lazy. Again, I'm not going to show it on the actual clamp because I just, you know, all it is moving when you get to an assembly. But whatever. Okay, and then this will go down. This will be cut into the piece at 4 millimeters, right? Yeah, 4 millimeters. Yeah, 4 millimeters. Cool. And then here we are. There's a piece. Have you used a fillet before?
Yep.
Cool. So we're gonna fillet these pieces.
It's fillet? I thought it was fillet.
Fillet, maybe.
Nah, it doesn't matter, but still.
You know what? I don't know. I think it's fillet because, like, you know, when you're like filleting something like an actual like food, like, isn't it spelled the same way? Pretty sure it's
I think you're on the right track, but just because it's like, since you used fillet for food, I just always said fillet to like have a clear distinction between. Like, oh yeah, I'm talking about SolidWorks.
Okay, I see what you're saying. Yeah, I don't know. Anyways, I use a 0.5 millimeter. I don't know, fillet, whatever. And here we are. We're just gonna go to all the edges, and now we have a bottom piece, and that is done. So what I do now is I save as. This is our 2 millimeter diameter spiral bottom piece. Cool. Now this is the fun part. This makes your life so much easier. You've used mirroring before?
Yep.
Yeah. This is, I mean, it'll just make your life so much easier if you know how to mirror. I do that. I do bodies to mirror, all that. Everything's good. Now I delete this part on a sketch. I just draw a big square, features, and what is going on here? Why isn't it letting me? Come on. Oh. Why isn't it letting me do that? It's in the way. All right, now sketch. Yeah, okay, now features. There it is. Wasn't letting me do it before. Then 18 millimeters. And see how it kind of cuts it in half.
Okay.
So now you have the second half, file, save as, and now we have our top piece. Look at that, same thing, same exact thing. Save you so much time.
Okay.
Yeah. So then, so now we're going to go and make the top part, which involves sketching on this plane, right, on this part of the mold. And then I'm going to take the corner to corner rectangle, go from there to there. And then I'm going to do it again, going from that portion to that portion. And now I'm going to extrude, no, not extrude, extrude lost space. So we're actually going to make something here. And we're going to do 6 millimeters because we have to go 3 millimeters to this face, and then 3 millimeters up to cover the bottom part of the bottom part of the mold. So there we go. There's that. Now tolerance again. Remember our good old friend tolerance. Any questions, by the way? Okay, cool. So now I'm going to sketch on that part. And center line, like I said, is going to be your best friend. Center rectangle. There it is. And making a square, smart dimensioning it to 14.1 millimeters. And then 14. And as you can see, look at that little space that's right there. You see that? So that's called the tolerance. It'll make it fit. And now we just extrude cut 3 millimeters all the way down to the next face. See, right to that face, and there we are. So now I have to continue the actual injection port through this part of it. So I make a face on right there, or I make another plane that is right here, and then I do a center line on the, I sketch a center line from that point to that point, and then I do a circle to that right there, and then I do an extruded cut. If I'm going too fast, let me know. I apologize. So, so now we have our hole all the way through. To be able to insert the pipette a lot easier, I do a, don't forget to save it. I do a fillet. We'll call it fillet since Jarek thinks it's fillet. So fillet. Do it 1 millimeter. So fillet 1 millimeter. There we are. Pretty much almost done. Very close to being done. Last thing we need to do is put the air hole. So we're going to sketch on this plane here. Before we do the air hole, any questions? No? All right, cool. So let's line it up so we can see it better. We're going to sketch on this portion of the mold, and I'm going to make a circle right there that is 0.7 millimeters in diameter. There's no particular way or where this is going to be placed. No. So it's kind of guessing, but you want it to be as far to the very end of the spiral or whatever mold that you end up making as you can, as well as having this little bit of room left to kind of make sure that the printer can print that mold.
Yeah.
So I think that's a good spot right there.
Okay.
So as you can see, it is still on this plane. It's not actually being like on this part of the mold. So, and then let me show you, I'm going to do an extruded cut through. Let me show you what it's going to look like on the inside. So there's the endings of those holes for the clamp. You got to make sure when you do these, you don't hit any of these holes.
Yeah.
So, which I won't. I'm only going to go 3 millimeters deep. So I'm going to do an extruded cut. That is 3 millimeters. As you can see, it's not even going to hit these. So there you go. It's now cut. It's cut through. Now we need it to come out the side because you could do it all the way through the hole, but that's where the clamp is. So you got to do it out the side. So I do it out this side. So let me line it up again, and I do this. So then I basically am going to sketch on this portion again. Sketch, let me do center line. See inside. So when I sketch on that plane, and I can still kind of see where these dots are, it's going to line up correctly. And then I do a center line on both of these, which is going to be half of 0.7, which is my hole diameter size. So 0.35 millimeters. 0.35. And then I like to use this 3-point arc to get it correct. And I do it again. Acting a little slow right now.
Why do you do a circle coming out of? Oh wait, that the piece that you're working on was originally a circle, right? We're just looking at it from the side view, so we don't, so we see that it looks like a rectangle. So
Yeah,
effectively making like an elbow piece.
yeah,
Okay.
yeah. It's exactly what I'm doing. And so I think it's smart to mention that. There we go. It's being really slow right now. There we go. So there's our perfect circle. And now see how you can see how it's like on that side right there? It lines up perfectly with that hole. So I'm going to do an extruded cut. So this is a guessing game. This is where you're going to guess to see where it fits up correctly. So I'm going to go do a side view right here. I have the number that it's going to, it looks like it's half. I don't know. But 9.16 is a good, when I did this before, I did this right before I made this video, so I can, go through faster and not have to worry about dimensions. 9.16, does that kind of look like half? Maybe 9.15.
Cut though, so as long as you get to that first initial piece, doesn't matter how much over you go over.
No, I'm just a perfectionist, but yeah, no, I mean, kind of, no, it does kind of matter how much you go over, because then I try not to, I do that middle piece to not have any over, like that circle kind of overhang on the ends right here. It's hard to describe that, but I don't want it to go all the way through, because then that circle will kind of just go here, and then I just, knowing airflow,
Yeah.
there's having like those sharp corners and everything. You just want it kind of smooth. So
Okay, yeah, that makes sense. Because we're working with circles, not rectangles.
yeah, so I just like to have it smooth, and as you can see how it's not smooth right here. It still looks like a little squared pocket, not square, but it's like it's very not smooth right there. So I just do another fillet, which is going to be on that portion right there, and it's going to be 0.3 millimeters. See how like it's a little cup now?
Yeah, yeah.
So
Okay.
yeah, that's all that is. And actually, it is now done. That is our injection mold for a 2 millimeter spiral. Now I'm going to show an assembly real quick with mating it to make sure it fits properly. Oh, I forgot to fillet on these portions right here actually. So these are going to be just so it's easier to kind of come together.
Yeah.
I'm going to fillet these portions right here. These are also going to be 0.3 millimeters. Yeah, so there it is. Now it's finished. So now we are going to make an assembly from this part. Oh, no, I was just staring. I thought there was something. It was going to do something else. It didn't. So we have our top piece. There it is. And let's hide these planes. And take all those little glue things off. So here it is. So now I'm going to insert the next component. Browse. We're going to do our bottom piece, which is right there. We can rotate our component.
You don't print it in the assembled view, do you?
No.
Okay.
I'm just, you want to always make sure it fits on here first before
Okay.
you.
That's what I was wondering. Yeah.
Plus, you need the assembled view to do flow simulation, which I'm going to do on the next video.
Okay.
So yeah, so now you know what mating is, right? You've done this before. Like, have you done assemblies before?
Yeah. Yes.
Okay. Cool. So yeah, so now I'm just going to mate these, not that piece, this edge with that edge like that. And then, okay. And now I'm going to do that edge with that edge. See how that lines up like perfectly?
Mm-hmm.
So that is exactly what we want. So now that is the assembled view. So if you can see that it lines up perfectly, and you can see the tolerance. You see that right there? You can see the
Yeah.
tolerance.
Mm-hmm.
So that is your assembled view. So I'm going to save as 2mm diameter spiral assembly. Save all, and then sounds good. So this is going to be the end of this video. Any questions about how my thought process of making injection molds or anything? Might have been pretty quick. I kind of went through this fairly quickly. So my thought process is basically just make a sketch, make the mold around the sketch, and then you just got to make sure it's compatible with actually physically handling it and doing it. So, all right, so this is the end of that first video, and then we're going to come right back for the next one. So I am going to stop the video now and stop.